Welcome to this deep dive into one of the most elusive concepts in statistics, degrees of freedom. Often abbreviated as DF, this number appears in every t-test, ANOVA, and regression output you've ever seen. But what does it actually represent? Today, we are going to use the budget metaphor to understand degrees of freedom not as a dry mathematical requirement, but as the precious currency of your data analysis. Imagine every data point you collect is a coin in your pocket. To gain knowledge, you must spend it. In its simplest form, degrees of freedom represent the number of independent pieces of information that are free to vary when estimating statistical parameters. Think of it like a GPS system. If you are in a one-dimensional world, a line, you need one piece of information to know where you are. In a 3D world, you need 3. If you have 10 data points, you have 10 independent bits of freedom. However, the moment you start calculating averages or trends, you begin to spend these points to buy your estimates. Let's look at the shopping trip scenario. Suppose you have a sample size of n equals 5. You have 5 independent values. But then you decide to calculate the sample mean x bar. Mathematically, the sum of deviations from the mean must always equal 0. This creates a constraint. If I tell you the mean is 10 and give you the first 4 numbers, the 5th number is no longer free to be anything. It is mathematically determined. You have spent 1 degree of freedom to buy the mean. This is why the denominator for sample variance is n-1. Section 2. The cost of estimation. In statistics, every time you estimate a parameter, you pay a price. In a simple linear regression, y equals beta 0 plus beta 1 hex, you are estimating 2 things, the intercept and the slope. If you have 100 observations, you start with 100 degrees of freedom. After estimating the intercept, you have 99. After estimating the slope, you have 98. This remaining budget is what allows you to estimate the error or noise in your model. Without leftover budget, you cannot measure uncertainty. Section 3. The danger of going broke, overfitting. What happens if you spend too much? Imagine you have 5 data points and you try to fit a 4th-degree polynomial. This model has 5 parameters. You have spent your entire budget. The curve will pass perfectly through every point, but your degrees of freedom for error will be 0. You are statistically broke. A model with 0 degrees of freedom for error cannot be generalized. It has mistaken the random noise for a signal. In data science, this is the root of poor predictive performance. Section 4. Degrees of freedom in ANOVA. When we compare multiple groups, the budget is split. We have between-group degrees of freedom, the number of groups minus 1, and within-group degrees of freedom, total observations minus the number of groups. We are essentially checking if the price we paid to categorize the data into groups was worth the reduction in variation. If the groups don't explain much, we've wasted our currency on a bad investment. Section 5. Statistical power and sample size. Why do we always want more data? Because a larger sample size means a bigger budget. With a massive budget, spending a few degrees of freedom on complex controls or multiple predictors doesn't hurt your ability to detect an effect. Statistical power is directly related to your remaining budget. The more residual degrees of freedom you have, the more precise your estimates and the narrower your confidence intervals. Section 6. Real-world implications. In fields like econometrics or genomics, researchers often face the small n large p problem, where the number of variables p exceeds the number of observations n. This is like trying to buy a mansion with a handful of pennies. Techniques like lasso or ridge regression are essentially discount coupons or debt management strategies that allow us to work when our budget is nearly exhausted. In conclusion, think of degrees of freedom as your statistical currency. Don't spend them all on complex models if you don't have the sample size to back it up. A good researcher is a frugal one, maximizing the insight gained for every DF spent. Remember, n-k-1 isn't just a formula, it's your balance sheet. References: 1. Moore, D.F. and McCabe, G.P. Introduction to the Practice of Statistics. 2. Gujarati, D.N. Basic Econometrics. 3. Walker, H.M. 1940. Degrees of Freedom, Journal of Educational Psychology.